This is part 6 of section 1.3, functions. We're going to start talking about both average rate of change and the difference quotient. If you took calculus in high school, these should look very familiar to you. They are very closely related to the concept of slope. In fact, they are slope. And once we add a slightly new concept to it in calculus, these become the definition of a derivative, which makes up the entire first half of Calculus 1. So to say that these two concepts are important is an understatement, okay? The average rate of change, which we abbreviate ARC, tells us how fast, on average, the function changes on a given interval. This, like I said, is a very important concept in calculus. So let's say we have 2 points. A, f of a. This is like a, you plug in the a value, what do you get for your y value? So this is like same as when we did in college algebra, it was x1, y1, x2, y2. Same concept, different notation. Then the average rate of change of f of x as x changes from a to b is defined by this, okay? Look right here, f of b minus f of a, b minus a. What I just said earlier was that this is the same kind of idea as x1, y1, x2, y2. It's just a different notation. Now, if I take that and apply it here, this is y2 minus y1 over x2 minus x1, which is exactly the definition of slope. Okay? So we really are talking about the slope of a line between 2 points. Now, what we're often going to be talking about, not just a line exactly, but we'll be talking about like maybe some points on a curve. And we imagine that we're drawing a straight line through there. And the slope of this line, which is what we're calculating, gives us an estimate of how quickly the curve is going up. That's what we're doing here. And this, again, becomes quite important later. So let's just do some calculations. We want to find the average rate of change of the function f of x is equal to 4x minus 9, where our a value is negative 2 and our b value is positive 2. Okay, so I've written this here. We can do b minus a easily, but first I'm going to calculate what happens when I plug in b, which is 2, and what I plug in a, which is negative 2. So f of b is f of 2, which is 4 times 2 minus 9. 8 minus 9 is negative 1. Okay, so now let's find f of negative 2, or f of a, sorry, which is f of negative 2, which was 4 times negative 2 minus 9. Negative 8 minus 9 will be negative 17. So the average rate of change is f of b minus f of a, negative 17, well, no, negative 1 minus a negative 17. Over b minus a, 2 minus negative 2. Be careful with your signs. I'm writing out all the steps here. Chances are you won't need to. Negative 1 plus 17 over 2 plus 2. 16 over 4, which is 4. So the average rate of change here is 4. One thing I do want to point out here is I started off with the b, f of b in the top and b in the bottom, a second. You can reverse this, where you do f of a here and then a in the bottom. What will change is the sign will change on the top and the bottom, but then once you do the division, you end up with the same solution. So at this point, if I had reversed a and b, I would have had negative 16 over negative 4, which still gives me positive 4. You just need to be careful that you're starting with the same one on the top and the bottom. So you can start with either one, it just needs to be the same on the top and the bottom. Okay? So let's do find the average rate of change of this one, where A is 3 and B is 4. So first, let's find h of B, which is h of 4, which will be 2 minus 4 squared, 2 minus 16, which is negative 14. H of A is h of 3. 2 minus 3 squared is 2 minus 9, which is negative 7. So the average rate of change is h of B minus h of A, so negative 14 minus negative 7, careful with your signs, over, I started with B here, so I start with B in the bottom, 4 minus 3. So this is negative 14 plus 7 over 1, which is negative 7. Okay, so this is basic average rate of change. Here we know specifically what two values we want to know the change between. So we're given an A and a B. Now, there is another form. Average rate of change and the difference quotient are very closely related. They're kind of looking at the same idea from two different directions. This particular formula is about halfway between them. Our book calls this a difference quotient, but it's also an average rate of change. The main thing here is that we don't know our B value. So we're making the formula we've had a little bit more general. So we know one of the spots where we want to have our average rate of change from, but not the other. So it's just a little bit more general. So we're going to do the same sort of calculations. We're just going to use this form instead, where we only know our A value. So if I want to find the difference quotient or the average rate of change here, I know f of x is given to me. I know A, x is just going to be x, but I need to find f of A. So f of A is f of 2. 3 times 2 plus 2. 6 plus 2 is 8. So what do I have? F of x, which is 3x plus 2. It may help you to keep it in parentheses for a while, especially when we get to the full difference quotient formula on the next page. So that's f of x minus f of a, and f of a is 8, over x minus a, and a was 2. So what do we have here? We have 3x plus 2 minus 8, so that's 3x minus 6 over x minus 2. You will often have a cancellation at this point. I can't say you will always have a cancellation, but often. These fractions will often reduce. And if you look right here, I can factor a 3 out of the numerator to get x minus 2. This doesn't factor, and it would have to reduce as 1, so I put it in parentheses. And then you can cancel these two. So this average rate of change is just a 3. Now let's do this one. Again, I need to find f of a. So f of a is f of 3, which will be negative 2 times 3 squared plus 3, which is negative 2 times 9 plus 3. Negative 18 plus 3 is negative 15. So the average rate of change is f of x, which is all of this, minus f of a, and f of a is negative 15. So this is, don't forget parentheses here, and this is over x minus a, which is 3. So doing some simplification here, it's going to be plus 15 over x minus 3. Now I need to see if this will factor and if this will reduce. And like I said earlier, the chances are good that it will do so. So I want to try to factor this, and it's always easier to factor if your first number is positive. So I'm going to factor a negative out of the numerator and then see if I can factor the rest of it further. And x minus 3 is not going to factor, but it will cancel out as a unit, so I'm going to go ahead and mark it like that in parentheses. Now I check to see if this will factor, and it does. I keep the negative on the outside, but 2x squared minus x minus 15 will factor as 2x plus 5 times x minus 3 over x minus 3. And then the x minus 3's cancel out. So your answer is negative 2x plus 5, which is perfectly acceptable, or you can also redistribute that negative if you wish. Either answer should be okay.